Hello, welcome to the channel, or welcome back if you watched the previous video on me doing this MIDI controller. Today we are going to expand our bare bones MIDI controller with LED and a button, foot switch. Where we left off last time was I did this kind of a schematic real quick, based on the suggestion from or recommendation from MIDI org. So we did try out a looper, RC500 Boss, and Digitech Wami, and we did learn how to wire everything up and send some commands, MIDI commands to our devices. Worked great. Have a look at the previous video. But today we're gonna expand on that, and this is the simplest interface. All pedals have something similar like this, LED and a foot switch. Can't get away from that most of the time. But by the end of this, we'll have a lot of the actual operations of the MIDI pedal covered. So let's get going. Before I continue, all of this you can see on in details. There's a link to my webpage. Everything is there, so you can just copy paste, try it yourself, do it that way. So here's the updated schematic. I added 3 components. That's it. You can even see later on how I wired this up. Now, this is nothing revolutionary. Very simple, 3 components. We could LED, a resistor, and a foot switch. This is kind of, I always put this kind of asterisk there, just to make sure that this depends on the LED that you're using. I don't know what I use, 1K for mine. Doesn't mean you need to use that one. It really depends on your LED. It's current limiting resistors, so it makes sense to put something. I wouldn't go under 1K, especially that in pedals we use low current, or at least I prefer to use low current LEDs, so they don't need much current anyway. One thing to note here, depending on the code we're going to be covering, depending on the wiring, we might wire this to either to ground or to here 3.3 volts. This is our high value, so that depends on the situation. Using LED, as I said, it's fairly simple. We won't be using LED that Pico already has built in, because that would be too easy. But in reality, you want to show something on the box, on the enclosure. So without some kind of a fancy stuff, you can't really do LED and show it on your enclosure like that built-in one. Now again, Pico can source quite a bit of current, relatively speaking. Again, just use current limiting resistor. All right, so to blink a diode, first of all, here's my very, I'm really wired up breadboard. I have LED connected to my, I think, pin 15. Here's the resistor, and here's the connection to the ground. Simple. Driving LED. So what we can do is just, if you go and you look at, Pico has loads of great kind of tutorials. This is, this is like hello world of Pico. We did way more complicated stuff in our previous in the previous video, so have a look at that. So But I'll be literally using this, example from Pico's Raspberry Pi Pico, how to teach kids to code. We'll use Tony. Here it is. Oops, I wanted to keep it like this. And I'm just gonna copy paste the code from Raspberry Pi Pico, right? And of course we're using MicroPython. Paste. This is it. Okay, let's see. Do we get? Yeah. You can see here, it's blinking. I suppose this frequency is 2.5 Hertz. That was quite easy. We defined pin as the output, this 15, where we connected it. We have a timer. Timer, it's initialized to every frequency is 2.5 Hertz, so it will blink, or this will call this blink 5 times in 2 seconds. That means, well, in 4 seconds it will blink 5 times, something like that. So it's periodic blink. That all it does. Calls this blink method led.toggle. That's really it. Nothing much to say about that. So let's go and add button here. Yeah, I kind of I'm just gonna wire it up real quick. So here, pin 14, and it's gonna get a bit more complex as we go along. So we're gonna add this 3.3. That's it. Button. Momentary switch. It's here. The thing is still blinking. Okay, so I'm just wondering where did they pick this up from. Anyway, so here I have a very simple. So we kept our LED there. Button. Now here is pin 14 as I wired it up there just a moment ago. It's input. That's what we're saying. And Raspberry Pi has pull down and pull up resistors. So lots of times you don't even need to use resistors. But in this case, this one is pull down. What this means is when my momentary switch is normally open, and because I reset, by the way, this LED is here still on, because when I reset Pico, I didn't reset Pico, I restarted MicroPython interpreter, so the LED stayed on, so don't worry about that. My switch is normally open, momentary switch, so pull down means that it will be normally low when I press the switch. That's why I had to wire up the other wire to 3.3 volts, just that. So that's just setup. And if button value, that means if it's high, we're gonna toggle the switch and toggle the LED. So what this will do while I hold my button, LED will toggle every half a second. Let's see if that works. So I'm gonna press it here, and yeah, works as expected. I leave it. Oh, that's it. Easy, right? So this is all great, but it's unlikely we're going to do it this way, right? So you saw in previous video, I was just sending commands over serial interface, you know, UART. I mean, things are inevitably going to get more complicated. And we are talking about here only LED and a switch and sending some commands over UART. You've seen that it wasn't very complex. But let's have a look at debouncing example. And let me see, I had a link somewhere for this. If I find it, I'll put it on the web page. But let's see something, you know, simple like debouncing. It's kind of a very, one of those problems is that when you press the button here, press the switch here, there's a mechanical connector inside, and it will kind of, before settling in, it might several times touch the contacts, so it will kind of bounce a bit. So that will be kind of it might give a wrong reading to the microcontroller, and the reason for this is you have to remember it's quite quick. It's like over 100 megahertz. So we're gonna do this. So we're gonna do a simple demonstration. What we're gonna do is here. This is exactly the same as before. We have our button or our foot switch. We have LED, but I added timer still there. But we have counter 0, and I'm just this on I set to false, and you'll see how I use this. So timer is there only for every second. It will call back this counter, and counter is going to just print the count. Okay, so that's it. It doesn't do anything. This part here is just printing the counter every second. The reason for this is I don't want to, as I said, 100 something megahertz microcontroller. That will fill up our screen very quickly. So here, while true, just the infinite loop. If button value, so if it is high, I'm gonna turn the LED on. If on variable is not, so if it's off, you should probably better name these things when you do your code. But I'm just putting it as true here, and counter, I increase counter by 1. So what this does is just detects when this on and is set to true and false. When I depress the button, LED is going to go off, and I'm going to tell it, oh, don't detect, don't count this, so I can count it next time, because I want to detect every press of the switch. That's very crude, very simple. We'll see how effective it is. So let's look at that. All right, 3, 6, 13, 24, 27, okay, 28, 29. So when I depressed it, it kind of bounced. But you get me, like, I pressed it now. I didn't press it 3 times. So that is just a demonstration of, what happens with, we deal with real life scenarios, and it's not really real life, and in theory and practice are the same, and then in practice they're not. So we have to take into account physical characteristics of whatever we're using in reality. So let's look at another option for debouncing. Okay, let's stop here. Let's see what I have here on my list. Oh, this was the... right. So this is how we possibly do it, and this is what I kind of should have, that was the link I was looking for. In MicroPython, there is an example of how to debounce a pin input. I'm just going to copy this. This is for Pi board, so for Pico it's going to be slightly different. So if I go and I just slightly changed my previous example, right? Slightly to include debouncing. Okay, so what this does, I'm going to real quick. Same thing here. We're going to do the same counting trick, but here is what I copy pasted from MicroPython's website. So you can see here. It just goes and what does it do? It counts this active for, it has to be settled for 20 milliseconds. So, what it does is wait for pin change. It goes in and checks the current value. And if pin value is not the current value, so it means that it debounces it just when it's high or low, when pressed or depressed or released. So say current value is whatever it is at the moment. So it's going to be low. So it goes in and make sure that at least 20 milliseconds we observe the same value. So if you press it again, it will bounce, debounce, and this will kind of reset it every time it detects that transition. And it's very simple. Making sure that for 20 milliseconds it's stable. So the only change in the previous loop is that we wait for this pin to change. So we don't mindlessly go into the loop. We just change. We just execute this on every state change. So let's see if that works. And you can see 0, 0. I pressed. It's only 1. I depress. And I did this in less than a second, so that's why it counted twice. Yeah, works, right? There you have it, simple debouncing logic. There are better ways, but that works. Now you can see things got a bit complex, way more complex very quickly. But we still haven't done this, how do we detect the button click? How do we detect long press, double click, double press, whatever? Well, at this stage, it's probably a better idea to use a library because, things get a bit... This is something that lots of people, wanted, needed. And if I go and I have a look at that, these are the things that you get out of the box with MicroPython. Like if you use that, and you can see here, you can check which modules are on, and there are some standard libraries, and I clicked on various different things here, at some stage, but you can try to see what's related to the hardware of the machine, and then but there's nothing around switches, okay? If you want to have a look what kind of other libraries are there, you can have a look at this awesome MicroPython. There's a list of all sorts of MicroPython libraries there, and let's see if we can find something. Libraries. Let's search for switch. Bottom. Oh, GPIO. Okay. So there's just to show you. Let's click on, for example, this one. There's a randomly chosen one. So if I go and is this, the switch class. It's not too big, 63 lines, but still, you know, what do we get here? Switch change. Okay, we still need to deal with whether it was a single press, double press, etc., etc. So let's see this one. You know, and we're talking about just for a very, very, very basic functionality. So I'd say it's better to go and use a library, you know. So what I'm going to use is I'm going to use this Async library. There's this MicroPython Async. What it does is it uses MicroPython's, I suppose this is micro async IO, which is implementation of CPython, whatever, async IO. So if I go and look at that, what does it say to me? Okay. What is it? It's a library to write concurrent code using async await syntax. This is so we can write concurrent code. If you think about it, the Raspberry Pi Pico has two cores, I think. So we should be able to run more than just one piece of code at a time. And also, you know, it's quite fast, so we can do some multi-threading, etc., etc. So we should be trying to use that. Again, there's nothing wrong with going simple and actually not even using that, because sometimes you want to be in control of what you're doing. But like here, I want to use it. There's also this thing about using events for programming that make programming slightly simpler. We'll see how that works in the end. But this micro async IO is baked into the firmware of the MicroPython, so comes handy. So what I'm going to do is this MicroPython async has already a library for push buttons and switches. So where is this? This is switch class. I'm not going to go into this, but this one is, you know, push button. There's a press function, release function, long press, double push. So there's a lot of it that kind of supports. I had to slightly, there is an example somewhere here, I think, but I had to slightly modify it because this was for Pi board, so we need to use it for Pico. So let's do this. Where's my Tony? Just here. All right. And it says, oh no, module name primitives. Okay. Actually, we need to copy some of the libraries, because if you look at here, let me see, where's the code? There's here, this folder primitives has all our classes. So I need to get that. I downloaded this earlier. So I'm just going to go to Tony, and I have folder there libraries. But in order to check, you know, just let me see here. How do we check this? Import. So, okay, we have libraries is in our path, so we can copy that there. I have to click on libraries here to make it, to select that folder, so I can now upload to this folder my primitives that I just downloaded from that. All right, so I have them there. Now you have to select lib folder, otherwise it will try to upload to the root. So let's try this again, shall we? Let me see, where do I have that? Prepare for copy paste. And keep in mind that code now is way more simpler than previously, with all that debouncing being handled by libraries. We are still using pin. We need this async IO, and we need push button from primitives. I'm going to use again toggle function here, led.toggle. It's just going to go. It will just toggle the LED. Okay, so here I put a note here. Push button to ground. We need to rewire. Okay, push button, because this is, I think you can customize this a lot, how you want to use your push button, and there's lots of customization. We are not going to go in there for this example here, but like here we're going to use pull up, so I need to rewire this real quick. This needs to go to ground. Conveniently, I have it here for my LED. All right, that was quick. No drama there. So I did that. This is my pin. No changes except this pull up red LED here. I just copied from, I said above, but that is from on website. Push button, that's all. I created a push button, and here press function is, what it does is calls the toggle method, but passes these parameters here, arguments. So just make sure that whatever is needed is, set up here. And now we have multi-threading or concurrent programs. So it's very important to make sure how to be careful how we share the data. But here we just send, this is our device. And this is dummy. Once this stop exits, as far as I know, my code will stop. So we need to work on this. This is async IO run. It just says to run this here. You would need to look it up for more details on how this works on the documentation on the website. But I'll cover that, some of that, And this is not working. As I said, as you may have noticed, I talk too much. So I'm just gonna run this again. I don't know if this is going to work, or I need to reset. Okay. I might need to reset now. Talk too much, so that main thread exited, and it's working. That was it. It's really simple when you look at it, when you use a library like this. As I said, this will run forever. I'm not sure what is the best way to do this still. So what I'm going to do is I'm just going to slightly change this code there. I'm just going to, instead of running it like this, I don't know if I can do this. Let me change this real quick. And this, but I just put this while true, and this never ends. This my app never ends, because this is the main method, main function. So when it exits, the program will stop. So that's what I noticed. So I just put here while true. I just put it to sleep for a minute, and it just keeps on sleeping for a minute until it finishes, and this will work here. All right. So where do we go from here? So now this is where we get to this really important bit. We're going to go and talk about adding some actual functionality here. So it's still working. Okay. Stop this. So we're just going to keep on building on to what we know. And I'm just going to press enter because I'm going to keep talking, and we may want to make sure that this is still working as I promised. Here, we're just going to add what we did last time. We still have pin 14 with our push button, our LED, and now I added this MIDI port, same as last time. Check out the previous video. I go into more detail how to set up the devices and how to set this up and how to know what to send. So in this case, when I press push button, I also call this toggle, just toggle the switch. But I also pass red and MIDI as well here, okay? And this goes into the loop. When I do the toggle, I toggle the LED, and then we toggle MIDI. I kind of covered that last time. We have to send, I call it off and on. So it's really minimum and maximum value for control change 1 command. So I pre-recorded here. This one is set up. Control change 1, toggle mode, play, stop. That's it. So when I press, it should start playing something, right? And when I press again, it should stop. There you have it. Full MIDI pedal with just like a few lines of code. Now, of course, this is not as useful as you would like it to be, because we won't be always, if that's all you want, this is fine. What's the name? Command change, control change. If you want to send, if all you want to do is send one command and toggle it, that's fine. That's your job is done. This will work perfectly. But that's not what we want to do. So we want to explore a bit more what we have, what options do we have on our here. So for example, we saw this, that there is this option toggle or momentary. The documentation doesn't speak too much about this in great detail. So let's see if I can find where my recent history, or see. I have so many documents lying around. So if we go and we look at here, parameter guide, and we go to MIDI, and there's a ton of different options. We look at source. This is our source. So MIDI command here. But source mode, if a momentary type Footswitch, such as this FS-5U, is connected as the source, you can specify how Footswitch operations will affect the value. Now, this is a bit tricky one, because what does that mean for us? Because we're using MIDI, so does it mean that when I change it to momentary, I'm still toggling? So what's that? What's with that? So if I go and I change this code a bit, and I say, for example, I think my let's say momentary means just, it doesn't mean what I think it means. It means just when I press the button, it immediately changes something. So say I send minimum value, it stops. And when I say maximum value for that command, it starts the loop. Well, that's not the case. So all I changed here in this toggle, if LED is on, I send this command change on or maximum value. If it's off, I send minimum value. And I print on and off. That's all I changed. I don't toggle it like that, like I did 0, 1. So when I press here, okay, I sent on, I sent off, nothing happens. Yeah, so it didn't really work there. If I go to, say, I'm gonna turn this off. And you can see how it's easy to, so I'm just gonna change this to 1. And this is to make it play reverse. So I'm gonna, it's toggle, okay? So it's very inconvenient when you have only one command. So I'll just press it to start. So off, nothing happens. So you see, it kind of it works like a toggle. You have to send minimum and then maximum value for that command, or it doesn't work. And it won't work if you send multiple times on. So if I go and change this to momentary, it's off, that's fine. On, it's reverse. Off, so momentary here works. So what if I change this, for example, I'll do this, say toggle. When I say instead of T1 reverse, I'm just going to change this to T1 stop. Okay? T1 stop. You would expect this will stop, but it won't. And this is a bit tricky because if I read documentation, it's a bit, it's totally unclear, right? Target minimum, it means immediate stop. Fade out, loop end. Okay, immediate stop. So it's going to stop immediately. Target max is going to be loop end. Let me put this to fade out. Okay. So what do you expect is going to happen? It's toggle. Okay. So off, on. Okay. So it did not stop. I have to press stop. And it's immediate stop. Okay. So I'm going to toggle it. Okay, toggled it. It fade out. So you're actually changing the configuration of this stop button, and it's toggling, so it's really pain in the back. But I can go and change this, assign to be momentary. Okay. So let's play. So I sent minimum value, it should stop immediately. Stops immediately. Okay. I sent on. And you see momentary here works Okay, this blows my mind. But it's really tricky. I wish they did this better job on explaining how MIDI works for the pedal. It's very easy for whammy. It's not really with RC500. You need to try all the values that you want to use. Again, the code isn't complicated. The code is simple, but the thing is, depends on what you want. So imagine I want to support lots of these options. It's very difficult because I need to have a way of handling this. When you press what you want to happen, etc., etc. We want to do this. We want to support probably lots of these things that the pedal offers. It's very unclear how to do this. It's very unclear what to do with the LED because you have no idea, especially when you're toggling, whether it's on or off, or when it's momentary, it's easy because you send minimum maximum value. But again, different things work differently. It's just a bit nuts. For Digitech whammy, it's clear because it sends one command to turn on a certain functionality and the other command to bypass it. There you have it. It's very simple. So what we're going to do next, you make sure you subscribe, because I'll be covering more stuff next time. You see, we covered a lot of things. We covered not just how to control. We just added hardware is not a problem. We added 3 components, and we did this. This was pretty easy to do. The problem now is how to use your target device, how to do the programming. So there's a few other things, and I want to support external pedal. I want to support expression pedal as well, and do everything into this into, let's say, final version of the pedal that will be. So stay tuned, stay subscribed. I'm sure if you've come this far, you don't want to miss this. Check out the website, and until next time.